Hello my friends, and welcome back to the Wow Machine channel. The HME copper tube plant operates with a fully automated and precision-engineered production line designed for efficiency and metallurgical accuracy. The process begins in the gas-fired preheating furnace, where copper bills are uniformly heated to achieve optimal extrusion temperature. In the extrusion setup, the sequence starts with billet introduction, followed by the upset and pressure relief stages to ensure even material flow. The billet is then pierced and forced through the die in the extrusion phase, forming seamless tubes. The process continues to the extrusion end position, where back-end sealing and shearing prepare the tube for the next operation. The cold drawing process refines the extruded tube's dimensions and surface quality. Using a 30-ton drawing bench, the sequence includes pointing, plug feeding, pickup, and drawing, ensuring high-dimensional precision and mechanical strength. The spinner block drawing process applies controlled reduction through die, point, and dent operations for smaller diameters. After forming, tubes are transferred using an automatic basket transport system to the coiling unit, where they are wound into 600-kilogram level wound coils for easy handling. The plant's automatic guided vehicle (AGV) system ensures continuous and safe material flow between production stations. A specialized heat treatment furnace provides individualized setups for different applications, including air conditioning, refrigeration, water heating, and solar thermal systems. Each coil is plastic film wrapped, end capped, and robotically handled to maintain cleanliness and prevent oxidation. With advanced automation, precision tooling, and thermal process control, the HME copper tube plant exemplifies high-efficiency, high-quality manufacturing for industrial and HVAC sectors. The cut-to-length line by OTEC machine is an advanced metal processing system designed for high-precision sheet cutting and coil handling. It efficiently transforms steel or aluminum coils into flat sheets of specific dimensions, with exceptional accuracy and surface quality. The process begins with coil loading onto a decoiler, followed by straightening through a precision leveler that eliminates coil set and ensures flatness. The roll feed system then advances the material to the flying shear or guillotine shear, where sheets are cut to the programmed length. The cut sheets are then stacked neatly by an automatic stacking unit for easy collection and packaging. Equipped with servo-driven controls, hydraulic tensioning, and PLC-based automation, the OTEC cut-to-length line guarantees consistent output, reduced material waste, and high-speed operation. It is ideal for applications in automotive, construction, and appliance manufacturing industries requiring superior dimensional accuracy. The Schuler Servo Press TSD1600 represents state-of-the-art metal forming technology delivering exceptional productivity and precision in automotive and appliance component manufacturing. This 1,600-ton servo-driven press is equipped with a highly dynamic power-feed roll system, a cut-to-length shear, and a modular tri-axis electronic transfer system, enabling high-speed and flexible part handling throughout the forming cycle. The servo drive system allows full control over ram motion, stroke profile, and forming speed, optimizing material flow and reducing tool wear. With its advanced motion control, the TSD1600 can operate at 24 strokes per minute (SPM) in transfer mode, achieving up to 50% higher output compared to conventional mechanical presses. When integrated with upstream blanking systems, it reaches 28 SPM, further increasing productivity by 75%. In progressive die operation, the servo press achieves up to 45 SPM, combining high forming accuracy with energy-efficient performance. The modular design supports a wide range of applications, from automotive structural panels to precision housings for washers and dryers. Through intelligent motion profiles and robust engineering, the Schuler TSD1600 ensures maximum forming speed, part quality, and overall equipment efficiency. The Doosan PUMA SMX 2600 stone is a state-of-the-art CNC multitasking turning and milling center, designed to deliver high-precision machining for complex components such as aircraft landing gear parts. This advanced machine integrates the capabilities of a turning center and a 5-axis machining center into one unit, ensuring complete part processing in a single setup, reducing cycle time and eliminating alignment errors. At the core of the SMX 2600 stone is its integrated twin spindle and lower turret configuration, enabling simultaneous machining on both ends of a workpiece. The main spindle delivers 26 kW of power and a maximum speed of 4,000 revolutions per minute, while the sub-spindle provides 22 kW and 5,000 revolutions per minute, allowing for synchronized transfer and secondary operations. This dual spindle system ensures precise concentricity during operations such as turning, drilling, threading, and facing. The B-axis milling head is a defining feature of the SMX series. With plus or minus 120 degrees swiveling range and 12,000 revolutions per minute rotational speed, it allows high-speed milling, contouring, and 5-axis machining of complex geometries. For landing gear components, typically made of high-strength materials like 4,340 steel, titanium, or Inconel, the rigid box-type frame and roller LM guideways provide superior stability, vibration dampening, and tool life extension. Machining begins with automatic workpiece loading into the main spindle chuck. The control system, powered by FANUC 31IB5, manages synchronized tool paths for both turning and milling operations. The operator can program advanced tool sequences using Doosan's EZ Guide conversational software, which simplifies multi-axis programming and ensures precise control over tool motion. The machine's 12-station lower turret can perform independent or synchronous operations with the milling head, allowing roughing and finishing to occur simultaneously. The Y-axis travel of plus or minus 210 millimeters enables precise off-center milling and drilling operations, while the C-axis control on both spindles ensures angular positioning accuracy for contouring and polygonal turning. For aircraft landing gear machining, this configuration allows for bore machining, keyway cutting, spline milling, and fine surface finishing, all within a single clamping. The coolant-through spindle system, high-pressure coolant delivery, up to 70 bars, and automatic chip evacuation system maintain optimal cutting conditions during long machining cycles. Integrated thermal compensation sensors monitor spindle and axis temperature to maintain micron-level dimensional stability throughout extended production runs. Every machine landing gear part undergoes in-machine probing and automatic measurement to ensure compliance with aerospace tolerances. Using Renishaw touch probes, the system performs adaptive tool compensation for wear or deflection, guaranteeing part accuracy and repeatability. Doosan's Smart Machine Networking, DNC, and predictive maintenance modules enable real-time performance tracking, vibration monitoring, and spindle load analysis. This ensures uninterrupted production and early detection of tool or component wear. Built for heavy-duty, high-precision aerospace applications, the PUMA SMX 2600 stone delivers complete machining from rough stock to finished part with unmatched rigidity, flexibility, and surface quality. Its combination of powerful dual spindles, multi-axis control, thermal stability, and automation-ready architecture makes it a cornerstone for modern manufacturing cells producing landing gear and other safety-critical aerospace components, where precision and reliability are paramount. The DMG MORI NLX 2500 SY is a high-performance multi-axis CNC turning center engineered for complex component manufacturing, particularly in the hydraulic cylinder division, where precision, rigidity, and surface integrity are essential. Built on a high-stability box-in-box structure, the machine minimizes thermal deformation and vibration during heavy cutting operations. It features a main spindle with 26 kW power output, 4,000 revolutions per minute speed, and a sub-spindle for synchronized machining, enabling full 5-phase processing without part reclamping. The Y-axis stroke of plus or minus 50 mm allows for complex off-center milling, drilling, and tapping operations. The turret system supports up to 12 BMT-55 powered tool stations, each capable of delivering 10,000 revolutions per minute rotational speed for high-speed milling accuracy. The X/Z-axis travel, 260 mm x 795 mm, provides wide machining flexibility for parts up to A366 mm in diameter and turning lengths up to 705 mm. Both spindles are equipped with integrated motor drives and C-axis control, ensuring simultaneous multi-spindle synchronization for precise contour machining. The Celos control system, integrated with Mitsubishi or Fanuc CNC technology, enables intuitive operation, automatic toolpath generation, and real-time process visualization. A coolant-through tool system, chip conveyor, and automatic tool presetter support continuous production cycles and maintain consistent quality under demanding machining conditions. With these features, the DMG MORI NLX 2500 SY delivers outstanding dimensional accuracy, repeatability, and productivity, making it a benchmark for precision part manufacturing in the hydraulic, automotive, and energy sectors, where complex geometries and tight tolerances define engineering excellence. SimpleComp Machining Division is responsible for producing the ultra-heavy components used in the company's 50,000-ton metal forming and press systems, representing one of the most advanced machining operations in Europe. Within the Krefeld manufacturing plant, massive machine tools, including CNC portal milling machines, horizontal boring mills, and vertical lathes, are employed to achieve the extremely tight tolerances required for these large-scale steel structures. The machining process begins with rough milling and boring of cast or forged components weighing up to 400 tons, followed by precision finishing using multi-axis CNC controls. These machines ensure exact flatness, perpendicularity, and dimensional stability across large surfaces such as press tables, guide frames, and cylinder mounts. Each operation is supported by computer-aided measurement systems and laser alignment tools to verify geometrical accuracy in real time. To handle the enormous components safely and efficiently, SimpleComp integrates automated positioning systems, hydraulic clamping units, and gantry cranes with lifting capacities exceeding 500 tons. The result is machining precision measured in microns, even for components several meters in length. This unmatched level of engineering excellence ensures the 50,000-ton forming press performs with maximum rigidity, reliability, and long-term operational stability, a hallmark of SimpleComp's world-leading heavy machinery expertise. STE Socket Set Manufacturer China is a leading producer of precision-engineered hand tools and socket sets, designed for industrial, automotive, and mechanical applications. The company integrates automated forging, CNC machining, heat treatment, and chrome plating lines to ensure superior durability and dimensional accuracy of each component. Manufacturing begins with high-grade chrome vanadium steel, which undergoes cold forging and precision machining to achieve exact tolerances. The parts are then heat-treated for enhanced hardness and torque resistance, followed by nickel chrome plating to prevent corrosion and provide a professional finish. Each socket and ratchet handle is subjected to torque testing and dimensional inspection to meet international standards such as DIN and ANSI. With advanced production equipment, strict quality control, and efficient packaging systems, Suite delivers reliable, high-performance socket sets, trusted by global distributors, workshops, and tool professionals worldwide. The elbow manufacturing process at Haitian Pipe Fittings, Vietnam, is a precision-engineered sequence designed to ensure high-dimensional accuracy and consistent product quality. Production begins with cutting the raw material, steel pipes or billets, into predetermined lengths using high-speed cutting machines for smooth and accurate ends. Next, the forming stage uses hydraulic or hot forming presses to shape the material into precise elbow angles, typically 45 degrees, 90 degrees, or 180 degrees, depending on specifications. The elbows are then beveled at both ends to prepare for efficient welding and strong joint integrity in pipeline systems. After forming, components undergo shot blasting, which removes scale and surface impurities, providing a clean, uniform finish. The products are then marked with size, grade, and batch identification for traceability. Finally, each elbow is carefully packed for shipment, ensuring protection and quality retention during transport. The production of a saddle-shaped ship hull panel using the Nieland cold-forming press is a highly controlled mechanical process that combines precision pressing and rolling operations to create complex, double-curved plates required in modern shipbuilding. The goal is to form thick steel plates into a saddle-shaped geometry, providing both structural strength and hydrodynamic efficiency for vessel hulls. The process begins with positioning the flat steel plate accurately on the forming bed of the Nieland press system, which is specifically designed for three-dimensional plate forming without the need for high-temperature heating. The hydraulic-controlled press rolls are programmed to apply uniform pressure in a predefined sequence. Through incremental deformation, the material is gradually bent in two directions simultaneously, longitudinally and transversely, creating the desired curvature while maintaining precise dimensional tolerances. The operator may switch to a press equipped with an integrated rolling unit, or alternatively, mount the rolling unit on the base press within approximately 20 minutes, offering great flexibility in the workshop. The rolling unit further refines the panel's curvature by performing continuous rolling passes that smoothen the surface and eliminate minor deformation marks. The cold forming process ensures a consistent radius of curvature and eliminates residual stresses that are typically induced by hot forming methods. Throughout the forming cycle, digital control systems monitor the applied pressure, feed rate, and roller angle to maintain optimal forming conditions. The Nieland system utilizes a CNC-controlled hydraulic drive capable of fine-tuning press force and movement in real time. This results in improved reproducibility and minimal material springback after forming. The finished saddle-shaped panel exhibits high structural integrity, uniform thickness, and excellent weldability, meeting strict marine classification standards. By using cold forming instead of traditional heat-based methods, energy consumption is significantly reduced, and the metallurgical properties of the steel remain unchanged. In shipbuilding applications, such panels are essential for fabricating curved hull sections, bulbous bows, and stern transitions, where precise geometry and smooth curvature are critical. The Nieland cold-forming press system thus plays a pivotal role in enabling shipyards to produce complex, high-accuracy hull components with exceptional repeatability and reduced production time. Gertine, the raising of a modern artifact by Niall Fahmy, is a remarkable demonstration of the angle raising technique, a traditional metal forming process that transforms a flat copper sheet into a three-dimensional vessel through precise, controlled hammering. The procedure begins with annealing, where the copper is heated and quenched to restore its malleability. This cycle of heating and cold hammering is repeated after every raising stage, a critical step to prevent cracking or tearing of the metal under stress. Inspired by ancient Egyptian pottery and the monolithic patterns of Ireland, Gertine stands as a fusion of historical symbolism and modern craftsmanship, a technical and artistic celebration of form, metal, and endurance. Each hammer blow is deliberate and cumulative, gradually shaping the copper upward and inward from the base, forming its elegant curvature. The form evolves one dent at a time, revealing the vessel's geometry through meticulous craftsmanship. FAMI uses an array of specialized hammers and stakes, each selected for a specific contour or angle, to sculpt the intricate surface. Once the structural form is perfected, the piece undergoes surface refinement, where the outer layer is treated to achieve a burnished copper patina, enhancing its warm metallic luster. The interior is then delicately finished with 23-karat gold leaf, applied by hand, to create a luminous contrast between inner radiance and exterior depth.